Hello, this is Dr. Mears, and today we are going to be learning about second derivatives and derivatives with other functions. So for our second derivative, it's really doing what it says, taking another derivative after we have done it for the first time. And when we take our second derivatives, it's going to give us a lot of information about the graph. What we're going to focus on is whether the graph has a local minimum or local maximum, or if it's inconclusive. And by that, I mean, if we actually had to graph something, a function that looks like f of x equals 2x to the fourth minus x cubed plus 3x squared plus 1, and look at the graph at x equals 0. Is the graph having a maximum value at x equals 0 or a minimum? And that's what our second derivatives are going to help us to do. So let's just put all that together, everything that I just said, and let's look to see what happens. Hopefully it'll have a better understanding than my introduction. All right, so examples. Find the second derivatives and state whether they have a local maximum, minimum, or is inconclusive. So first we have to take the first derivative. So let's do that. So f prime of x equals first derivative, everybody. Okay. 4 times 2 is 8x cubed minus 3x squared plus 3x, and then the 1 drop, plus 6x. Sorry, do not write 3 plus 6x. And then the 1 drops out. Okay. Next, we do f double prime of x, which means that we have to take the derivative again. So from this one, so that's called the second derivative. 3 times 8 is going to be 24x squared. Wow, my hand is not doing what my brain is telling it to right now. And then 2 times negative 3 is negative 6x, and then plus 6. Okay, so now that we've taken the second derivative, we want to see, okay, does the graph of this right here, of this original function, does it have a maximum? So does it have a point that looks like this at x equals 0, or does it have a minimum? Does it have a point that looks like this? Which we're going to find out. So what we do is just substitute it in. So f double prime of 0 equals 24 times 0 squared minus 6 times 0 plus 6. Anything multiplied by 0, so we're going to cross those out. So f double prime of 0 equals 6. Okay, so what does this tell us? This tells us, if we look at this number, if this number is, right here, greater than 0, then it is going to have a minimum. So that's what this is saying. If our answer is greater than 0, then it has a minimum. If it was less than 0, it would have a maximum. And if it was equal to 0, then we couldn't tell whether it's inconclusive. So since 6 is greater than 0, it has a minimum. And you actually are going to see, here's that graph of this original function. And here's our x-axis. We go to 0. We look at the graph, and guess what? It does have a minimum. So this told us that at x equals 0, our graph has a local minimum. Pretty cool. Without even having to graph it, we can tell if it has a min or a max. That's what second derivatives do. Let's look at another example. Whoops, I do not want you to see the graph yet. Okay, there we go. All right, let's look at another example, and then we're going to check our answer with the graph. All right, so we're going to have to take the first derivative. It's all sticky. Okay, there we go. Okay, perfect. Let's take the first derivative. Y prime equals 8x to the third minus 8x. Okay, let's take the second derivative. So doing it again, 24x squared minus 8. Now we need to know at -1, at x equals -1, so we have to substitute -1 in. Does it have a local min or max? -1 squared minus 8. This is a 24. So y double prime equals 24 minus 8. And so we are going to get 16. 16 is greater than 0, so we should be looking for a minimum. And let's look. So here is our graph. Here is our x. So let's go over to -1 right here. Look down, and guess what? Here is our minimum. So we were able to tell from the original graph, does it have a minimum or maximum at that point? And that's pretty neat for the second derivative. So that's what it helps us to do. It does help us do other things, but I'm just going to be focusing on this one today. All right, let's move on to derivatives with other functions. Now, we have been using our derivative rule where we multiply n by the coefficient and then subtract -1 from the exponent. So this is our normal rule that we have used. However, there are other functions such as the function of e and natural logs and logarithms, sine, cosine. So there are all of these other derivatives. And please don't be nervous if you're an IB. When you sit for the IB exam, they're going to give you the formula sheet. So this is the formula sheet. And if you look at it, we're going to see here's our rule. Here are all the derivatives. Derivative of sine, cosine, e, natural log, chain rule, product rule. All of the rules are here. So refer to this. You do not have to memorize all of these different ones. You have to know, though, to go to the formula booklet, because if you forget how to take the derivative of the natural log, it's going to tell you what it is. So please use the formula sheet. You do not have to memorize this. Fill your brain with other things of what these mean rather than trying to memorize, because you don't need to memorize those. But you need to understand how to do it. So let's do them using our examples. So we have let f of x equals e to the x, and we're not just going to take the derivative, we're actually going to find the line tangent to the curve at 0, 1 in the form y equals mx plus c. So first we have to take the derivative. So now we haven't taken the derivative of e to the 3x. I'm going to explain how to do that. So f of x equals e to the 3x. When we take the derivative, we're going to have to do two things. We're going to have to take the derivative of the 3x first, and that's going to come down in front here. So the derivative of 3x is 3. Then we are going to take the derivative of e to the 3x, and as you'll see, the derivative of e to the x is just e to the x. So we are just going to bring down e to the 3x, and that's it. That's what you do. So this is, you first take this, number 1, that's the first one, and then you just bring that down. So we have taken the derivative. We need to find a line tangent. And when we find the line tangent, what are we going to have to do? Yes, we're going to have to put this x value in so that we can find the slope. Now on your calculator, you have the button above the natural log button. So all you do is you can just put that into your calculator. So f prime of 0, you're going to get being 3. This actually drops out to be 1. This will be 1, e to the 0 is 1. So, and then times 3 is 3. But we're not done because this is our m. So we're going to be doing y minus y1 equals our m, 3, x minus x1, 0. So I just substitute the point in. And a little simplification here to get it in y equals mx plus c. And here is my answer. So a little review and something new, our new rule for our deriving e to the 3x. Okay, next, number 2. Consider the function 4x sine 2x. So again, we're not used to taking the derivative of sine, but in your formula booklet, the derivative of sine is going to be cosine, and guess what? The derivative of cosine is actually negative sine. Ooh. Okay, so doing these, we have to remember that we are going to have 2. We have the 4x, and then we have the sine 2x. Remember, we have a u and we have a v. So this is hopefully reminding you of the chain rule. And so that's what we're going to do. So first, find f prime of x. So f prime of x equals, we're going to bring down our u term, which is 4x, and take the derivative of sine 2x. So now, sine 2x is going to change to cosine 2x, but we also have to take the derivative of this one. I'm going to call it w, uvw. So we have to take the derivative of the inside. So the derivative of 2x is going to be 2. Okay, that's it. Then we're going to do plus, because the chain rule, plus. We have to take the derivative of the first one, so u, so the derivative of 4x is 4, and then just bring down sine 2x. That's it. Then we just bring down v. That's it. So for this first one, we just brought it down. We changed sine to cosine 2x, and then we took the derivative of the inside here, 2. I'm going to simplify this a little bit. I'm just going to multiply 4 and 2. 4 and 2 is 8x cosine 2x plus 4 sine 2x. And that's that. So it's like you have to take the derivative of multiple things. It looks simple, but you actually have to break it down. I like breaking it down to u, v, and w so that I remember that I have to take the derivative of everything. All right, find the gradient. So I need to find m of the curve when x equals pi over 2. So all we're doing here is just substituting pi over 2. So f prime of pi over 2 equals 8 pi over 2 cosine 2 times pi over 2, 4 sine 2. Okay, I am for this one, so all I did was substitute it in. If you get this on an IB exam and you substitute it in, you get a point. If you get stuck solving it and you get the wrong answer, that's okay. You still have a point for the problem. So just make sure you show all of your substitutions. What I'm going to do is I'm going to simplify this. 8 pi over 2 is really 4 pi. Cosine, I forgot my s, and then I'm going to simplify this because the 2's can drop out to just cosine of pi, plus 4 sine, again, I'm just going to drop those out, pi. And so now I can substitute. We know that cosine at pi, which is right here, the x value is going to be -1, and the y value is 0. So I'm doing a little bit review here too, cosine and sine, and this is going to be pi. So I'm doing a little bit of review. And so now I can substitute that in. F pi over 2 equals 4 pi cosine, net times -1, plus 4 sine times 0. And I can get my final answer as f prime of pi over 2 equals, this is going to drop out, -1 times 4 is -4 pi. That's a negative. And that is my answer. Okay, little review, something new. Let's keep going. All right, and number 3, this is going to be the last example. There's 3 here. We are going to let f of x equal 6x minus the natural log of x, 4. Okay, I got a little rambunctious there. 4x is greater than 0. First, we're going to have to find f prime of x. So if we go back to our formula booklet, because I don't know how to find the derivative of natural log of x, we are going to see, if we look right here, natural log of x, if we take the derivative, is just 1 over x. So that helps us out. So if we find f prime of x equals, let's take the derivative of 6x, this one first, which is 6. Then we take the derivative minus, and remember, the natural log of x, taking the derivative, we just change it to 1 over x. So let's do that. And that's it. We're done. Okay, let's do the second derivative. Find f double prime of x. So before I actually take that double distribute, I am just going to change this x to x to the -1. That's just going to make it better. Now I can take the second derivative. This is going to drop out. -1 times 1 is +1. So +1x, I'm not going to write that 1, and 1 minus 1 is -2. All right. That's it. Let's go on to the last one. So what we have to do is solve. We have to set the derivative equal to the second derivative. Ooh, let's see what happens here. So we're going to do 6 minus 1 over x equals x to the -2. I'm going to do a couple things. So again, this is a little bit of review. Hopefully it's going to help everybody out before the IB exam. I'm changing that to 1 over x squared. And what I'm going to do here is I'm actually going to I'm going to subtract 6 minus 1 over x minus, so if I subtract it out from both sides, 1 over x squared equals 0. I get it equal to 0. I can't solve with my x in the denominator, so what I'm going to do is I'm going to be multiplying everything by the greatest power here. So because x has the power of 2, I'm going to be multiplying by an x squared, and everybody gets that. And watch what happens. This is really pretty. So when we do that, we get 6x squared minus x, because this is a 1, remember, x squared divided by x, you subtract their exponents, and then this is going to drop out here, so -1 equals 0, because anything times 0 is 0. So now what I have is a quadratic function. We can't factor this. So what we're going to have to do is use the quadratic formula. And the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So a here is 6, b is -1, and c is -1. So if you forgot about the quadratic formula, I'm reviewing it right here. So let's put all of our numbers in. So I have the opposite of b, so the opposite of -1, plus or minus the square root of b squared, -1 squared, please remember your parentheses, minus 4 times a times c all over 2a. Now let's clean it up a little bit. X equals, this is going to be a +1, plus or minus. If I put everything in here, I'm going to get 25, and 2 times 6 is 12. So I am now at x equals 1 plus or minus 5 all over 12, and I'm going to split those up. I'm going to have x equals 1 plus 5 over 12, and x equals 1 minus 5 over 12. And so 1 plus 5 is going to be 6 over 12, which reduces to 1/2. That's one of my answers. And this is going to be x equals -4 over 12, which reduces to -1/3, and that is going to be my second answer. And so we were able to solve, we were able to find these are actually x-intercepts of this equation here, which is pretty cool. So what we did is we set this first one and the second one equal to each other because that's what it asked. Again, if you're an IB and you're taking the exam, set them equal to each other. You get a point, and it's a points gain with this. Then I simplified it by multiplying everything by that highest exponent, and I got 6x squared minus x minus 1. Realizing it was quadratic and I had a quadratic formula, I substituted my numbers in and simplified, and then I found our solutions, which is x equals 1/2 and x equals -1/3. This has been a lot. We learned about second derivatives, and we learned about derivatives of other functions. Please remember, you can find all the formulas in the formula book, so please utilize your formula book when you are taking the IB exam, and good luck.